Hey everyone, and welcome. Today we're jumping into a topic that sounds way scarier than it actually is: the matrix. Seriously, forget all the complex math for a second and just think of it as the most organized, powerful spreadsheet you've ever seen. Let's get into it. I mean, think about it. We've all been there, right? You've got sales figures over here, user data there, inventory counts somewhere else. It's just a sea of information, and it's easy to feel like you're drowning. Well, a matrix is pretty much the perfect solution for all that chaos. It's this really elegant, simple, structured way to put all of that information into one neat, tidy package. It's your life raft. Okay, so to get going, let's just tear this thing apart and see what it's made of. We're going to look at the basic anatomy of a matrix, and trust me, it is super straightforward. So at its absolute core, a matrix is just a grid of numbers. That's it. You take your data, you line it up in these horizontal rows and vertical columns, you slap some brackets around the whole thing, and bam, you've officially made a matrix. It's literally a storage box for numbers. Now, there are two key terms you're going to hear all the time. First is the order. That's just a fancy word for its dimensions or its size. We always read it as rows by columns. So a 2 by 2 matrix has 2 rows and 2 columns. Then you have the number of elements. This one's even easier. It's just the total number of numbers inside the box. You just multiply the rows by the columns. And here's something really cool. Every single number inside that matrix has its own unique address. We write it as A with a little ij next to it. The I tells you what row it's in, and the J tells you the column. So if you see A21, that just means you go to the second row, first column. Simple. Okay, now that we've got the basics down, let's meet the family. It turns out there are a few different types of matrices, and they each have their own special thing going on. Think of this next part as a field guide for spotting them in the wild. First up, we've got the core family. A square matrix is exactly what it sounds like. The number of rows equals the number of columns. A row matrix, yep, just one single row. A column matrix has, you guessed it, just one column. And a null or zero matrix is the easiest of all. It's just full of zeros. See? Easy enough, right? Now, building on that, we have the diagonal matrix. This is a type of square matrix where the only numbers that aren't zero are on the main diagonal, that line that runs from the top left corner down to the bottom right. Everything else, zero. Now take that idea and get even more specific, and you get a scalar matrix. It's a diagonal matrix, but it has one extra very important rule. Every single number on that main diagonal has to be the exact same. So they're all 5s, or all 2s, or all whatevers. Okay, so you might be thinking, wait a minute, what's the real difference between a diagonal matrix and a scalar matrix then? That's a great question. And this slide shows it perfectly. A diagonal matrix can have any old numbers on its diagonal, a 1 here, a 5 there, no problem. But for it to be a scalar matrix, those numbers must be identical, like a 5 and a 5. So here's the key takeaway. Every scalar matrix is a diagonal matrix, but not all diagonal matrices are scalar. And finally, we have the star of the show, the big one, the identity matrix. This one is a huge deal. It's a scalar matrix where all the diagonal numbers are just the number 1. And why is that so important? Because in the world of matrices, this guy acts just like the number 1. If you multiply any matrix by it, nothing changes. And that is an incredibly useful trick. All right, so we've met the players. Now let's see how to play the game. It's time to get into some basic arithmetic, how we can actually start doing things with these matrices. You're going to love this because the rules for adding and subtracting are so simple. There's really only one rule you have to remember. The matrices have to be the exact same size. That's it. If they are, you just add or subtract the numbers that are in the same spots. And for scalar multiplication, you just take one single number and multiply it by every single element inside the matrix. Done. Okay, adding and subtracting is useful, for sure. But matrix multiplication, this is where the real power is. This is the engine behind everything from 3D computer graphics to training AI. It is truly the backbone of this whole subject. Now, I know it can look really complicated at first glance, but I want you to burn one simple phrase into your brain. Row by column. That's it. That is the entire secret to matrix multiplication. Okay, let's break this down and do one together. To get the very first element of our Lou answer matrix, we take the first row of matrix A and the first column of matrix B. As you see in step 1, we multiply the matching elements. So 1 times 1, 3 times 4, and 4 times 2. Then for step 2, we just add those results up. 1 plus 12 plus 8. And what does that give us? 21. And that is the very first number in our brand new answer matrix. To get the rest of the numbers, you just repeat that same row-by-column dance for every single position.
All right, theory is great, but what's the actual point? Let's see how all this stuff works in the real world by using what we just learned to solve a simple logic puzzle.
So here's the problem. We're told that these two matrices are equal. Our job is to figure out the value of x. Now, it might look like some weird algebra problem, but it's not. It's really a matrix rule problem.
The entire key to this puzzle is in that one word, equal. What does that really mean when we're talking about two matrices? It's actually incredibly simple. It means that every single element in the same spot must be identical. The top left has to match the top left, the bottom right has to match the bottom right. You get it. So, look at our puzzle. The x is in the top right corner. The 3 is in the top right corner of the other one. If they're equal, then x has to be 3. And just like that, puzzle solved.
You see, matrices aren't just about crunching a bunch of numbers. They're a powerful system for logic and for organization. From what they are, to all the different types, to how you can actually use them, you now have the fundamental tools. The only question left is, what puzzles are you going to solve with them? Thanks for watching.